Going live now. Okay, we should be live now. Yes, sir. Yep, live. क्या हुआ?
कुछ नहीं रहा रवि मेरे को क्लास में से देख रहा और मैं ऐसे नीचे बैठा हो रहा आई भी क्या अपन
हाँ live है अभी. All right. Welcome everybody. Welcome to another episode after a long time. We almost took a break of I don't know a month or more due to hold on one of my okay yeah due to some unforeseen circumstances we had to take a longer break, but we are back. And to start with, at least, it's going to be just both of us. Kedar will join us. Unfortunately, our expert, Mr. Kshitish Kakoradikar, won't be here today. But we have Amod in the chat already. Welcome, Amod, our loyal viewer. All right. So, anything you want to say, Satvik?
yeah so after a long time I mean yeah we had to take that break. I think it was much needed to understand few things, but yeah, best part is we are back again, and today is going to be a very interesting discussion on you want to say it or should I?
No, you can say it.
So 3D printing is something that we guys talk a lot about, and uh, mostly it's just a brief understanding that we have when it comes to 3D printing and the discussions that we have around. So today we kind of thought of checking on those pointers, wherein what 3D printing is, how it is today related to almost every industry. You name it, there could be a 3D printing application. And we are hoping to discuss and touch few points on that today, because we think it is going to make a difference in the coming years.
Yes, Amod is joining us. So we'll have another guy joining us in, one of our most loyal viewers. And welcome Neha in the chat. Thank you for tuning in. So yes, 3D printing. For for me it is like until Amod joins. So for me, like 3D printing has been like a love-hate relationship because I mean earlier I used to think, oh my god, it's amazing, and then in between I was like, I don't know, it's really not going at the pace that I thought it would or something like that. And then now again, like when I uh, do today, when I look at the 3D printing again today, now I think it's picking up a lot of pace, and in between there was a lot of garbage, but again I think we are now we are tunneling down to what is really useful with 3D printing rather than trying to do everything with 3D printing. So yeah, that's great.
I think, I mean, before we touch base on these points, so there is this very interesting fact that I would like to share, and it is whatever engineering we do. So mostly engineering is all about solving problems, and when we think of proposing a solution using basics, so be it anything like in civil engineering, in computer science, in computer engineering, there are certain basics. But our engineering capabilities are actually limited to the manufacturing capabilities, or I would rather say, engineering capabilities are, they are basically dedicated, or a lot of in, capabilities that or problem solving we can do is dedicated by the manufacturing capabilities, meaning if you have certain limitations in manufacturing, that would basically help us, or that would want us to change our way of looking at things, and then just because we could not manufacture, we had to propose a different solution. So that is what I wanted to basically highlight, and it's very interesting. I mean, not just in terms of the core streams like mechanical engineering, civil, or whatever. We are actually limited. Even it is evident in software industry. So if basically if we talk about virtual machines or containers, both of them, when we were only talking about virtual machine or virtualization, that had brought up some solutions. So basically we were limited with that, but then later on there came containers, and then everything evolved. So what I wanted to say is, as we move on and as we bring in different methods in terms of manufacturing, the capabilities and the solving problem solving exposure that we have increases drastically.
Mm-hmm. Yeah, I agree. First of all, welcome, Amud.
Hi guys,
Hi. Okay, your voice is really low, Amud.
Yeah, if you can speak closer to your mic, or maybe.
1 second. I'm going to switch to my microphone.
Okay, yeah. Because I don't think in Zoom I can increase individually volume of people for some reason. That's so dumb. But yeah, I mean, until then, I agree with you, Satvik. Like the limitations that are brought around by the manufacturing practices, it's um, like Elon always says that, especially nowadays, he stresses a lot on the fact that manufacturing is much more difficult than coming up with a design or the design phase. Because coming up with a new design and stuff, it's you do it one time and you need to get it right. But when you put it into mass production, then you have to repeat that process multiple times and get the exact same result, which makes a lot of sense. So um, when you talk about limiting factors, like that's what happened, I think, with 3D printing at first. Like, coming up with 3D printing different stuff was all amazing and flashy in the beginning. But then when you want it to scale and when you want it to become mass production, that's when you need to start doing quality control and trying to achieve the same results every time. And that I think, to tie to your point, that limited in bringing in 3D printing into mainstream for a long time, actually. Like I said,
So,
right? Like I
so
one second. So, like I said, I had this love hate relationship. Like I said, because in between, I was a little disappointed that it's not a lot of um, advancement in 3D printing, and I think this was one of the factors limiting it. So, yeah.
I think the best example about is Maruti 800, and Amod can be a
We lost you, Satvik.
Can you hear me now clearly?
It's louder, but now there is echo because I think you're using the laptop microphone, right?
Yeah, somehow I don't know why.
Yeah, that's fine. So am I?
Yeah, you were stuck,
Uh,
Satvik. You just came back.
okay, so I think there is an issue at
Uh,
my end with the internet today. I don't know. But the point was that I wanted to say is, Maruti kept manufacturing Maruti 100 until few years, and then their goal was to minimize the cost, and that actually influenced the way the car was
Right.
manufactured. So, I mean, it goes hand in hand. Today, you're talking about Elon, so there are gigafactories, and that gigafactory, the pipelines, the whatever is set up over there would actually influence their production, their capabilities of producing goods.
Mm-hmm.
So, I think 3D printing, if we talk about its origins,
Yeah.
correct about those timelines. There was this guy
Satvik,
known as
we lost you in between, so you might have to start again with from the origins of 3D printing.
uh, okay, let me give me a sec.
Mm-hmm. No problem.
Okay, I hope hamper any much. So so I was talking about the origins of 3D printing. I came across
Uh, we were losing you again. When
today
you're
is a
not
doomsday.
yeah, when you're not talking about 3D printing, you're fine. When you start talking about 3D printing, we lose you.
I think the first conceivable evidence or the reaction people got of 3D printing was in movies.
Mm-hmm.
Uh, if you remember Jurassic Park, they show 3D printing and they sculpt Velociraptor's vocal cord. And that's
Oh,
the first time when I saw that, oh shit, there is something called as 3D printing. This was the first Jurassic Park, I think in the 1970s, or sorry, 1990s, something like that, by
mm-hmm.
Spielberg.
Yeah, yeah.
And if you remember the scene where they go to the excavation area and they talk about how modern technology is helping us to understand more about these creatures, and they show a rudimentary box wherein
Okay.
there is like a slider onto which there is
Mm-hmm.
a additive machine, and then it sculpts a vocal cord of a dinosaur. So that was the first time I saw a 3D printer, and
Yeah. I
at
don't
that
even
time I
remember
did
that
not
scene.
know what it was, but it
Hmm.
was quite fun to see it.
Yeah, I mean, yeah, that's a good reference actually. I don't even remember that scene, but yeah, that's pretty fascinating, man. In 1990s, so yeah, I think even like 3D printing as an idea is not very new, but I think the feasibility of actually being able to do that is what we have now, and I think it's a very good example of starting off in sci-fi and starting off as a sci-fi thing, but now being like a real thing, you know.
Okay,
Yeah, that is there. That is there.
I hope I stay on the bandwidth now. Uh, so I was talking about the origins, and while I was reading about it, there were some articles, and the origins of 3D printing actually dates back to 1920s,
Oh, really?
and it's a story of a guy who kind of came up with an idea to make decorative articles, and he patented that idea.
Oh.
So there is still the patent. You can still find it on the USPTO website,
Mm-hmm.
and his name is Ralph Baker.
Okay.
And back in 1920s, he patented this technology, and that document still discusses how he kind of came up with an idea to make these items like baskets or maybe something else.
Hmm.
So it was just a layered way of manufacturing those stuffs.
Mm-hmm.
And then later, if I spell it correctly, Hideo Kodama, he is a guy, Japanese guy. He then came up with the additive printing or additive manufacturing as we know today, the
Mm-hmm.
stereolithography. He came up with that idea in 1981 and then kind of introduced it in properly in 1984.
Mm-hmm.
So we could say that then 1980s would be the came into existence and people were actually starting to use and make use of that technology.
Okay. Yeah, that's fascinating.
So
I didn't know about this 1920 guy, man. That's crazy.
yeah, and even in terms of the computer manufacturing today, the chips the way they are manufactured.
Mm-hmm.
If you talk about the Intel chipset or anyone for that TSMC who these
Mm-hmm.
guys manufacture those chips, they are actually also using a type of lithography wherein they have a silicon and then on that they etch these transistors. So,
Mm.
so the I cannot name that right now, but the same method is being used in
This is going to be a difficult
Did we
episode.
lose him?
Yeah, this is going to be a difficult episode.
Oh, that's fine.
Yeah. Yeah, I'm not sure if etching is considered as a part of 3D printing, but yeah, I mean the parallels I can see what Satvik is saying. So yeah. So I mean let's. Is there anything else about history that you guys want to add out here for the of 3D printing? Because I mean, if
Pardon
Uh,
me?
I said, is there anything more about the history of 3D printing that you want to add in here? Yeah.
I mean, in terms of its origins, that's it for it. But then later on, as in when, so there is a very interesting fact. Maybe we can relate this to something what Elon did. Unfortunately, most of our discussions come back to Elon. We are such a great fan of the. These guys patented the idea of 3D printing, and then in early 2010, I think 2009, these patents expired, and that to boom. And even I can relate to this that it was back then in 2010,
Satvik,
2011.
Satvik, we are losing you a lot. Maybe you can try just audio, because
I think I should do that. So
yeah, yeah.
back in 2009, the patents expired, and after that, all these manufacturing giants tried to started to get into the uh, uh, market in terms of they also bring up 3D printing as a technology. But then for the most of the time in the early 2000, it was patented, and that's the reason it was closed source. So that is what
Okay.
I have understood so far.
Who had patented it?
I am not sure. There could be a long list of it, but yeah, the story goes like that. So
Oh,
the
okay.
reason this is the reason what struck me while I was reading this is, I mean, Elon decided to open up his patents around electrification of cars. So that's how the industry boomed in, I don't know how much, 5 years of time. So if 3D printing patents would have been made open that back then it would have been at a better stage today.
Yeah.
That is what I feel.
Yeah, definitely. I mean, the patent thing is always this very weird topic, at least, because like it's like with this whole open sourcing versus closed sourcing something, or restricting. And yes, patents allow companies to become bigger because they earn royalties and stuff, but at the same time, it limits the development. So, like, I feel like patenting way too early in the life cycle of a new technology causes more harm than anything else. But if that patenting comes at a very right time, where like you don't try to patent everything, like they, oh, we have a 3D printer, so let's patent the fucking head of the 3D printer. um, don't do that, right? Like, let people explore, try to make better heads, and then someday you can patent something more useful, which is like, yeah, okay, we 3D print XYZ thing, and that we can, or we are using this new polymer, and that you patent, then it's a different story. But anyways, that's a little bit of a different topic. But
so I have to ask something. I mean, I have a little bit of knowledge of 3D printing because I've done
mhm.
it myself.
Oh, nice.
However, um, is it true that I mean, it's not true, but obviously 3D printing came after there was computer and there was softwares, 3D modeling softwares, and after those 3D modeling softwares were designed, people wanted to materialize those shapes into believable parts or parts that
Right.
they would print and scale and check if they would work. So was it something like how technology trickles down from space industry to regular markets? So was it like it was invented for some really high tech research and then it trickled down to the masses?
I think it was a rather more opposite, like 3D printing. um, like it became like a buzzword, and then everybody was trying to 3D print everything. But the major application, as it was talked about, was always like manufacturing. That's it. Like, because you don't, when you, for example, if you're trying to create a car door, and you have like 10 different cars, then you are going to end up creating 10 different molds and hundreds of them for mass production, right? Versus if you can 3D print it, then it's just you have to give it a model and the same machine will do it. for 10 different models. So that's where like the manufacturing is just manufacturing was where it started, but now it has started trickling or creeping up rather into things that are much bigger, which we'll talk about in some time, like rockets and stuff like that. So I
So maybe
think
I'll add a
yeah.
few pointers over here. And
Mm-hmm.
while I was talking about Mr. Hideo Kodama, interesting fact that in the 1980s, these guys came up with this idea from, I mean, while they were working with the Nagoyo Municipal Industrial Research Institute. So it's a very big name, and that's a Japanese location. So these guys kind of, I would rather say, or maybe brought up the term of additive manufacturing. And I mean, it also it came as a surprise to me while I was reading about this. Till now, whatever manufacturing you have seen, like, if you want something like a lathe machine,
Mm-hmm.
or for example, if you're building a car, you're welding different parts, even
Mm-hmm.
those parts are actually cut from a sheet of metal.
Right.
So, in general, all of these methods are known as subtractive manufacturing as a group.
Mm.
So, which basically, in general, means that you have raw material, and that material is basically cut down, stripped, or trimmed into the final object, and then whatever part is cut down, that goes for waste.
Waste. Right.
So essentially, when these guys came up with additive manufacturing, the whole notion of how these parts, or maybe how these objects were manufactured,
Mm-hmm.
completely changed.
Right.
And that kind of also changed the way we look at or the experience that we have into manufacturing. So, for example, these guys who forge metal,
Mm-hmm.
forge knives, who forge metal objects. The practice of forging from molten metal, or when we manufacture car engines, you
Mm-hmm.
pour it into a die
Yeah.
casting. So all of these have been for centuries. Like, if you look back, our great grandfathers and their ancestors used to forge shields, used to forge weapons
Mm-hmm.
using the same method. So as a society, we have large amount of experience in subtractive or other such or manufacturing techniques other than additive manufacturing. So
Right.
when we came up with additive manufacturing, there is still, I would rather say, we have just touched down 5% of what 3D printing or what additive manufacturing can do for us.
Mm.
Whereas there are a lot of problems that have arisen since we have came up into this, or where we have extensively talking about this technology and using it. So I would rather than say that we are still in an infant stage,
Right.
where a lot of problems need to be addressed. So something like machine learning has boomed into last 5 years. Same
Mm-hmm.
thing is kind of happening with 3D printing.
Yeah. Yeah, I think it's more in like the moderate stage, but yes, I agree with you. Like, I mean, it's a weird stage actually. It's not even to beginning. It's not even proper moderate. It's in between those also. Like, I think there is useful stuff happening with 3D printing. But at the same time, I also think that there is a lot of things that can be explored and done with 3D printing that we are not doing yet, just because it's not yet cost efficient, and some other issues that we might not have solved, like structural integrity and stuff like that.
So I have something to add to that. Now, since I come from automotive background,
Mm-hmm.
uh, and we are working on specialized parts, the parts that would go in the vehicle interior. So 3D printing is used in lightweighting, first of all. Uh,
Lightweighting.
yeah, like for
You mean
example, the
reducing
things,
the weight for a product or
yeah,
something?
lightweighting of materials.
Okay.
In so the things that you can 3D print are, of course, plastics, ABS, and all those kind of
Mm-hmm.
things. Then there are metals that you can 3D print, and
Right.
now they can also 3D print alloy. And then
Alloys.
there is, of course, alloys.
So when you say you can 3D print alloys,
Yeah,
does that mean you still like let's say you're 3D printing a metal, right? Which
yeah,
is, let's
yeah.
say you're purely 3D printing steel. So that
Yeah.
would be like you would have the steel powder, and then a laser melts it and creates a layer of it, something like that, right?
I wouldn't know the specifics of that,
So
but
Okay, okay.
so
I've been
the
working with
yeah.
suppliers such as Stratasys and all these
Mm-hmm.
kind of companies which 3D print metal. Uh, so right now, the example that I would give is if you've seen Mercedes-Benz AMG vehicles.
Right.
So the seats of the AMG vehicles are
Mm-hmm.
made by two things. First, the inner part of the seat is made out of metal, that is regular molding and fabrication.
Okay.
Um the outside of it is made out of foam, and then the embellishments, which is leather and all those sorts of things.
Mm-hmm.
And the back panel,
Mm-hmm.
the part on the back, that entire shape that
Mm-hmm.
is made out of carbon fiber, and that carbon fiber is
Mm.
3D printed, and it is
Oh.
3D printed entirely out of 1 meter by meter bread, and that would reduce up to 3 to 4 kgs of weight.
Oh, really?
So that is something very interesting I got to know. And then secondly, metals, as I said, they are printing metals left, right, and center in
Yeah.
hypercars and exotic cars.
Oh, really?
Uh, all McLaren vehicle interiors, you will see that
Mm.
most of their interiors are 3D printed, literally from the shape of the steering to minute buttons and
Oh.
things like the chassis itself. These cars wouldn't have a chassis.
Right.
What they would have is a monocoque.
Okay.
What that means is how a conventional vehicle or a product is designed, where you put pieces by you construct
Mm-hmm.
the skeleton by molding, or sheets of metal is put together by bolts.
Right.
Nowadays, the entire shell is made from one piece, and that is 3D printed.
Oh.
So that is heavily used in exotic cars and expensive things, obviously, because it is expensive.
Mm.
The technology is expensive for
Yeah.
now, and it is
Yeah.
not yet trickled down to masses. But
Correct.
in my college, we had a 3D printer. It was
Mm-hmm.
called a Galaxy class 3D printer. And what we would do is when we would have our design projects,
Mm-hmm.
we would build a model, and a low poly model or a high poly model, and
Okay.
then 3D print it, and then see it in our hands, how it feels like,
Mm.
touch the surfaces and all. So
Yeah.
that's how I got in my first exposure of 3D printing. It
3D
was, I think,
printing.
in 2012 when I saw it in my hands,
Oh, nice.
and I was blown away. I was like, "This is magic. How can this work?"
Yeah, I
So
think.
so
Uh,
so
Go
for
ahead.
the most part, 3D printing is still mostly used for prototyping, and maybe I can share some details later in the discussion. But uh, there are certain disadvantages around 3D printing that because of which we are still not able to scale that up.
Mm.
And I mean, if we look at printing something on a sheet of white paper, it's basically the printer throwing these ink particles onto the paper, and the particles stick to the paper. So that is how printing works. All
Yeah.
print media, everything that we get today is this basic principle of a head putting out or
Mm-hmm.
throwing some particles of ink onto a sheet,
Yeah.
Right.
which it sticks to it. So basically, the same thing applies to 3D printing. And as we discussed about subtractive printing, subtractive manufacturing, and additive manufacturing. On the additive manufacturing part, basically the the techniques or methods that are applied to 3D printing, they are kind of categorized into brief three major categories. One is centering, another is melting, and the last one is stereolithography. I hope
Mm-hmm.
I'm pronouncing them right. So, in a nutshell, all of these actually also work on the base principle of, as Nirmik mentioned, the laser is etching some metal powder. So basically, that's a kind of sintering method, which is also known as direct metal laser sintering,
Mm-hmm.
DMLS.
Mm-hmm.
Yeah.
And in all of these categories, or in all of these methods, all of the machinery that is developed around 3D printing actually incorporates the idea of either using lasers or using high energy beams onto a raw material that can melt, that can form
Mm-hmm.
the expected shapes.
Correct.
So in basics, I mean, whatever application or whatever. So even if you talk about 3D printing organs, 3D printing, anything using polymers, the same thing applies. You have a head, and that head is basically either emitting lasers or it is emitting a molten raw material, and then it is
Correct.
eventually forming around the shape.
Yeah, yeah, that's actually, I think we didn't mention this, but for anybody who hasn't had a lot of exposure to 3D printing, we're talking terms like additive printing and stuff. Um, I think we should have mentioned this before, and that's our bad. But what you do with 3D printing is basically you're printing 3D objects instead of printing like you do on paper. You print, you know, letters and stuff or pictures. You're doing a 3D object basically, like you take, for example, simplest one or the most common one is printing using some polymer or some type of plastic. So there's like a thread of plastic that goes into a like a pen like structure. I mean, you can say like it's a pen tip, and that pen tip at that end of it melts that thread, and it will go around the shape that you want, and it will go on depositing that melted plastic, and that's how a shape will form, you know. So
Yeah.
like if you want to create a ball, it will first start by doing this, and then it will, you know, go wider and wider and wider until a certain point, and then it will again start going inner, like, you know. So that's how it
Correct.
basically 3D prints.
It also depends on the quality of 3D model that you have made,
Okay.
because the more detailed and the more
Mm,
efficiently you make it, the better your 3D printed object will be.
right.
The first step is the model and the 3D software that you use, that has to be absolutely spot on.
Mm-hmm.
Then the material that you choose also matters, because as conventional manufacturing techniques, where you would first build a frame, then you would build a surface that goes onto the
Mm,
frame, and on the frame you would paint or you would do post production, like you
right.
would draw shapes or you would do that. In
Correct.
3D printing, it's just one material, and
Mm-hmm.
the post production is usually not there. The surface that comes out is generally very crude.
Yes.
So if you can imagine a very clean and a very shapely 3D model which does not have any imperfections on the
Mm,
surface, a surface,
yeah.
that would come out beautifully.
Yeah, I think right now what you see with, I mean, that's one of the drawbacks of 3D printing still is the structural integrity, right? Still with metal 3D printing, they have achieved same structural integrity because it's basically melting powder and forming as if it's a unibody, basically, which rather would be much more structurally strong than stacked stuff, you know, because unibody designs are usually much more stronger than assembled designs, right? That's why you
Right.
see, like, even from small things like laptops, which have unibody design, can be made thinner
Right.
in terms of the body than if you try to create, like, you know, conventional, like you create a bottom separately, a top separately, and stuff like that. So that's there. But in terms of the polymers, at least still, or the common, like you see 3D printing, if you Google what you see, the 3D printing machines, that's the whole thing. Because it's like plastic being stuck to each other, the structural integrity is still, in that case at least, it's still not a uniform unibody thing. Because by the time you come back to a surface, you are not melting anymore the body below you. So it's a solid
Uh,
body, and then putting.
so
I
Nirmit,
think
while I maintain some part of your statement, I mean that is correct.
Mm-hmm,
But
mm-hmm.
right now, what is happening is, you imagine a product not from the A surface. Imagine it inside out.
Inside the
So
surface.
imagine you are designing the bumper of a vehicle,
Hmm.
okay, or a bumper, or just say you are making a
Okay.
mixer grinder,
Hmm.
and the body of the mixer grinder is entirely made out of a 3D printed part.
Okay.
So the rigidity of the part would have been decided by what lies on the B surface,
Okay.
right?
So you
So
mean inside?
so. I think what Amod had
so
to talk about is, I mean, no matter what method we use for printing the objects, it is basically governed by its design. And what he's trying to
correct.
say right now is, even if you're using 3D printing and whatever technology or whatever advanced technology you have, or machines that you have in terms of printing, it basically also comes down to the way the part is actually designed. So in specifically in terms of cars, so Amod being from car background, and even I agree upon his points. So, I mean, what he has to say in this case. So if you don't have a proper design,
Yeah.
no matter if you use subtractive manufacturing or additive manufacturing, the rigidity that is provided by either of them is kind of also governed for the most part by its design.
Yeah, so just
Uh,
to put into perspective, the body will start making the 3D printing will start with the inner mesh. It will be a lattice structure like a
Yeah.
honeycomb structure, and then
Yeah.
it will grow to the outer body. So if you design the part like that, if you pre-plan it, so
Right.
3D printing also gives us an advantage of pre-planning and early collaborations between OEMs and suppliers. So you can like work with them at a very early stage and not wait for the molds or all these kind of child
Correct.
parts to be
Correct.
designed. So
You
this
can
is
do
how it
like the
works.
agile kind of stuff where you like iterate over the designs pretty fast
Correct.
and from the early stages basically.
And then they are using various kinds of polymers or various kinds of plastics that can actually flex. Now there is a very interesting concept from it's not a concept anymore, but Adidas has a shoe. It's called Futurecraft, and if
Okay.
you see the outsole of the shoe, it's a very tightly designed lattice structure, crisscross structure that is entirely 3D printed. So when you apply pressure on that, if you imagine walking on that, it will squeeze and it will, like
Correct.
go how
Correct.
you walk. You remember those tires that came out on YouTube where they
Yeah,
did
I
not
did.
have
Yeah.
Continental.
conventional wheel? It was like a rubber and
Yeah.
it was,
I remember. Yeah, I remember.
no,
It
it was
was
like
more like a zigzag lines in between, right?
sort of,
Something
sort
like.
of. So imagine
Yeah.
something like that. Imagine
Yeah.
something like that. So if you design the product like that, it will come out with the desired result. But being said that, there is obviously a lot of things that have to be considered while mass production. And these products that I just mentioned are niche products, and they are
Correct.
very, very they are specialized. They are not used in.
Like
So
even
I
with.
still,
Yeah. Go ahead.
yeah, I still remember the. I mean, you were talking about the pen, and I still remember the Kickstarter program that these guys had. The pen was called Three Doodler.
Yeah. It's there. It's
So
still it exists.
yeah,
Like yeah.
I mean, you can still see its Kickstarter pages, but there are a lot of replicas of that same idea in the market now.
Yeah.
And I remember that is the first encounter when I came across something which is known as 3D printing, and for the most part, I mean, anyone who is very new to 3D printing or who is not from the manufacturing background, they basically refer to 3D printing as using plastics or using polymers to print out objects, small objects for prototyping.
Yeah.
But to even it was to my surprise when I learned this that 3D printing actually came up from uh, the automotive industry, from the manufacturing industry, and it was basically thought of with using metals. And the early 3D printers used to use raw metals and alloys, or mix of different metals, and then they used to print in required objects, and that's how basically people either used and a lot of applications were into areas where there were the parts used to be in a thermally or an area where there used to be a lot of heat, and that's the reason the cooling system used to be embedded in the part itself instead of using an external system or something like that,
Right.
as well as in terms of aerospace industry. So a lot of today's engine parts of airplanes and engines are actually 3D printed just because of the accuracy that these guys get in terms of designing the airflow and other aspects of the engine.
Correct.
Yeah. Yeah. I mean when.
The insides of a jet engine, the fins, they are 3D printed because
Oh
you
really?
cannot have any shut line or you cannot have any gap on it. So something like that. This company called BASF is high into all these innovations. So I was working on a project with Volvo in my college where I found out that they would 3D print the inner parts of uh, for a company that makes high quality chairs,
Okay.
and the structure of the chair was made as such that it was a polymer.
Mm-hmm.
But while 3D printing, there was a certain species of fungi that they would use. And when the polymer was sent finally for post production and it was put into an oven, the fungi would get activated and it would fill the spaces and it would create a cushiony surface. So, all
Oh,
sorts of innovations, all sorts of things are being done.
damn.
It's pretty
That's
interesting.
crazy.
Yeah.
Wow. Okay. Yeah, I never knew about that. I mean, it seems like the 3D printing has actually become quite mainstream more than I imagined ever, to be honest. Um, and it's being used in pretty innovative ways. Like I feel like the B2C side, which is or the flashy side rather, I'd say, of 3D printing, which we get to see on YouTube or whatever, that still seems very immature if you just look at that. But then these such type of implementations of 3D printing kind of make it actually worthwhile, I feel like.
So right now, the limitation of the 3D printing is obviously structural strength and feasibility.
Hmm.
Apart from that, the amount of space that the 3D printer can work around is also very important. So the
Oh,
largest 3D printers are done by this company called Stratasys. You guys can check it
okay.
out. They have a 2 meter bed. I think that
Okay.
is the largest size that you can do. So if you want to do a part which is more than 2 meters, then you will have to 3D print two shapes and then put them together.
What about,
And then
I mean, we are going to come to talk about it anyways, but what about relativity?
relativity as in.
So there's a company called Relativity which 3D prints complete rockets. Uh,
So when they say they 3D print complete rockets, uh, I will have to again check on this, but
So
mm.
they would have 3D printed parts of it and they would have assembled it.
Oh,
Usually
yeah,
that is
yeah,
the
yeah.
no,
I
no,
mean, yeah,
no,
of
no.
course. It's not like the whole rocket building together.
not the whole rocket, not
Yeah,
the
yeah,
whole
yeah.
rocket.
Of course not.
The centrifuge of the rocket. So for example, if the rocket is maybe 1 or 2 meters in diameter,
Mm-hmm.
I mean usually something like that. I think
Yeah.
that can be, but
So
not more.
let me add to what Amod is saying.
Mm-hmm.
And basically, the 2 meter bed that he's talking about is majorly a part of centering. The 3D printing machines or 3D
Mm-hmm.
printers who incorporate centering, they
Correct.
basically require a bed on top of which they basically print out. So in a very basic scenario, the machine has a platform that
Mm-hmm.
can move up and down.
Right.
And how it works is basically a thin layer of powder. It can be a metal powder, it can be polymer,
Mm-hmm.
something like nylon or something. That powder is laid out on the bed,
Mm.
and the laser is basically then etching. I won't say etching, but then it is basically heating up this raw material and then printing it layer by
Yeah.
layer.
Right.
So in such a case, in such 3D printers, the capacity and the capability of objects that can be printed is basically also governed by its bed.
Correct. Oh, okay. I see. I
Uh,
see. Yeah. Okay.
but
Then that's the
but the
difference with
point,
relativity. But okay.
yeah, the point that you had is these 3D. There are other type of methods which basically come in melting.
Mm.
And this 3D printing, so if I mean the basic example or the best example which you guys can relate to is 3D printed homes. So
Yeah.
what it does is there is a head, and that head is constantly pouring out concrete in a structured format, or in,
Mm-hmm.
in a format where the head moves.
Yeah.
So layer by layer, it is depositing some material
Mm-hmm.
in a given structure. So that is also known as deposition method, or maybe it can be thought of as a method wherein a head of the printer is actually depositing the raw material. So other words for such kind of printing is direct energy deposition, wherein so for example, if you guys know welding, how
Yeah.
welding works is you have a rod, and which is basically melted at site, with using high voltage. So similar kind of method is used for 3D printers who choose or incorporate the melting strategy,
Correct. Yeah.
wherein even these guys who make rockets, they basically use this alloy, which is either molted, it's basically the by using high temperature, either by using lasers or electric electron beams, the raw material is it's molded in a fashion that it can be then laid off by a head.
Yeah.
So that's a completely different category of how 3D printing can be done. And
Yeah. Yeah.
a major advantage of this method is you basically are not restricted with size
Base
of
size. Yeah.
the object that it can be built with. Yeah,
Yeah, yeah, that's actually well pointed out, because the relativity that I'm talking about, what they have is, they obviously everybody needs to have a bed, but it's not the way you said, like it's not powder laid out and then it moves up and down and then laser doing that. They are doing actual normal conventional 3D printing type, which is melting the metal. So they have you know reels of metal alloy strings that go into the
exactly.
metal head, and they melt
Yeah,
it, and they're just welding it on each, like basically they're welding it on as layer by layer.
Yeah.
So they
yeah,
have built long, so diameter wise, yes, they have built probably a couple of meters or something, like the fuselage or the booster, the propellant tanks and stuff. So yes, they are not too wide, but they have pretty much built pretty long structures, like the whole. So let's for example take a solid rocket booster that attaches besides a lot of rockets, right? So maybe let's like a 10 meters or 20 meters. So they have built like a 10-meter long unibody using those 3D printers, because the printer just keeps going up, I think so.
yeah,
Yeah.
exactly.
Yeah, I should have said that what I was pointing out was strictly speaking to manufacturing, like mass production manufacturing techniques,
Oh
where
yeah, yeah, yeah. Yeah, yeah, we
because
come back to that same thing again.
yeah,
Mass
X and
production.
Y direction. So I guess Y direction you can go how much ever
Mm-hmm.
you want.
So
Yeah.
I'll want to add a few pointers now, since we have came across, or since we are on the same page. There are certain serious disadvantages about, or maybe I won't say disadvantages, but certain aspects of 3D printing which we have not yet matured, or the problems that I talked about earlier, they still exist.
Mm-hmm.
And if you look at forging or molding using hot metal, so the way it works is, if you're working with metals, basically every metal has a crystalline structure.
Yeah.
We had this in our chemistry. So whatever structure these elements have, they basically are influenced by temperature.
Mm-hmm.
So if I'm heating a steel rod, and then I can bend it, and when I bend it, basically its structure or crystalline structure changes.
Yeah.
And for the most part, we kind of have experience in terms of molding, melting, and then mending all these manufacturing techniques.
Mm-hmm.
But what happens in terms of 3D printing is, for example, if the speed of the laser that is used to melt the powder,
Mm.
if it is too high,
Mm.
that layer might have pores, or it can get
Yeah.
pores in it. If the intensity of the laser is not proper, then what will happen is there can be grooves that are introduced in the layers that are then printed, and so on and so forth. So basically, problems like these in the long run actually then introduce cracks.
Yeah.
And then basically researchers kind of look at what is the fatigue fractures,
Mm.
what are the fatigue what is the fatigue tolerance of a particular method, and what crystalline green structure does the object have. And I mean, there surprisingly there is still a lot of research that is yet to be done around these problems. And if you look at it from an academic point of view, there is a lot of papers, lot of research that is going on, and to kind of solve these problems.
Mm-hmm.
I came across one solution. For example, if you today look at printing photos on a paper, on a white paper, basically the printer head moves from left to right,
Yeah.
and line by line, that is how it prints down the objects on the paper.
Mm-hmm.
Whereas in case of 3D printing, this method, so the way my laser head would move,
Mm-hmm.
actually also influence how strong the object can be.
Yeah.
So the point that I had was the way. So there are, I mean, there are different strategies. So this is known as laser scanning.
Correct.
The way the head laser it scans, and then it kind of puts that object on the platform. There are different strategies, and these different so some of them are like island scan strategy or helical scan strategy. I mean, we can look at this after these podcasts, but
Mm-hmm.
what was surprising to me is this strategy actually influences the rigidity and fatigue properties of the material which is built or which is printed. So it was very interesting, and there is a lot of research that is going on around this.
Mm.
So we use a software called Inventor Fusion. It is by
Okay.
Autodesk. What you can do in that software is you can assign materials, and you can also say what kind of manufacturing process you would like to go ahead to produce certain parts.
Mm-hmm.
It will simulate everything, like you said. It would simulate the stress it would go through. It would simulate the extreme temperatures and the vibrations, all those kind of things it will go through.
Uh,
And if you do that, that is another step that helps you to plan better
Correct.
your design itself. And
Yeah.
when you plan the design itself, then the model or the part that comes out naturally comes out
Yeah.
better
So
than.
there's another point that I wanted to ask. It's a little not exactly related to what you're already talking, but so we earlier talked about the wasting in a subtractive method, right? I mean, of course, a metal, even if you're cutting it out, is going to go back to recycling. It's not really wasting, but still, for like if you look at a particular window in a production line, yes, it's wastage for them. So but even with 3D printing, I've seen like there's support material needed a lot of times, right, to
Correct,
print.
correct. Yeah.
So what do you guys have any insight on like the wastage percentage? Is it really that low? um, or how much does the support material affect? Because if it's metal, then you're gonna have to probably also print that support metal, which you'll have to then cut down and grind, and then again that is the same thing, right? Like you're gonna send it back to recycling or something.
So this again depends on the design of the product, how you design it. So for example, if
Mm-hmm.
you design a cube, you wouldn't need support. But if you would design a rhombus, and if
Yeah.
you keep a rhombus in a
I
somehow
think I can add a few points on that.
Mm-hmm.
And from what I understand, on an average, 70 to 90% of raw material is actually wasted when it comes to subtractive manufacturing. And the reason for that is, for example, if on a CNC lathe machine, if you want to carve out a crankshaft,
right.
and to do so, you basically have a huge cylinder of whatever metal it is. I'm not sure crankshaft is actually it is forged on a lathe, but just an example, there is a shaft which we need to design and manufacture, and for
Mm-hmm.
that we need a cylindrical metal rod.
Yeah.
So after the shaft is basically, the excessive material is removed, the nature of this material basically it does not goes to the manufacturer. Now,
Mm-hmm.
the thing is, even if it is recycled, they need to send it to someone who is actually recycling it.
Right.
So
Okay.
there, the cost saving is not much, or I would rather say it is zero.
Mm-hmm.
And plus, when it comes to buying that raw material, you are actually investing in the overall rod rather than the subtracted part. So when it comes to subtractive manufacturing, that kind of percentage, 70 to 90 is it's total wastage.
Okay.
And even if we talk about the material that is wasted in additive manufacturing, it is in the percentage of, it can be single digit or it can be 10 to 20%.
Oh, okay.
So that kind of advantage is there. And another is like, if you talk about centering, or if you talk about relativity, who kind of incorporate the decomposition method. deposition method. So
Deposition.
even in that case, their raw material wastage is not much. It only gets wasted if the part fails to meet certain criteria.
Okay.
So that is the biggest advantage of 3D printing when it comes to cost saving. Uh, and another point is, Amod mentioned earlier that when it comes to manufacturing car parts, basically there is research, a lot of research that is put into, and the best part is this research basically happens using computer aided design. So, for example, if you want to design suspensions of a Formula One car, so thermal testing, stress testing, all of these tests can actually happen virtually in the computer aided design software.
Yeah.
And that is how basically you kind of save on material cost, save on iterations. So I remember, I think
Correct.
it applies to relativity itself. So the way they have rapidly prototyped their rocket engines,
Yeah.
it was majorly influenced to the fact that they had this capabilities to do so in a virtual world, run down tests, and then come up with a prototype, and then do some physical tests. So that is how 3D printing has been playing a major role in saving costs.
Yeah. Yeah, I think although while we are also talking about the plus points, just to mention a couple of minus, I think 3D printing from what I've seen is pretty time consuming as compared to normal manufacturing. Because if you have a mold and stuff like that, for
Yeah,
example,
it is.
again going back to like let's say just producing a door, you put the metal in the mold, you cool it down maybe couple of hours, 3 hours, or then you maybe do something to harden it, more processes, right? Maybe, but 3D printing I think takes quite a lot of time because it's limited by the heat production, by the rate at which the head can move, and like you said, because it and the rate also depends on heat and the structural integrity that we want to achieve. Because if you move too fast, it might create pores and stuff. So that I think is something that is definitely limiting because 3D printing is quite slow, and if we can get that to be faster, that would be great.
So that is actually a disadvantage, and that's the
Yeah.
reason. I mean, you rightly mentioned a point that if something that can be manufactured using die casts, you would rather invest your money in making that die and then manufacturing at scale. So it's an advantage over there. But complex parts, so complex parts like engine parts, airplane
Yeah.
engine parts, rocket engines, or if you want to design, say for example, you want to print out certain elements of a car using carbon fiber, or some other complex parts, like for example, if I had an injury and one of my hip bone is completely fractured and I need to replace it with some metal part, doctors actually can scan, do an MRI, and basis on that MRI, the softwares today can formulate a predicted object that can fit in like a
Yeah. Yeah.
Lego brick, and that's where 3D printing actually shines, and it gives us the capability to manufacture these complex parts. So
Correct.
definitely, the time that is required to manufacturing these parts is a bigger disadvantage, and I would rather say it also adds up to the cost of these machines, which actually allow us to do printing. So even they are very costly, and they are made with a generic implementation in mind. And that's the reason, again, if your printer has like 500 by 500 centimeters of bed, you are limited by that. So even if you want to if you want to print bigger objects, you need to buy a bigger printer. So that investment comes in. So these kind of go into the disadvantages of 3D printing.
Yeah.
I completely forgot about the medical sector, but as Satvik mentioned,
Yeah.
uh, prosthetics are made out of, they are mostly 3D printed because obviously you cannot have a common die for so many people
Yeah.
because everybody's anthropometric data is like vast.
Correct.
So that's also where 3D printing comes into place.
Yeah, definitely. That, and I think we won't be touching too much in detail, but there's also like organs being 3D printed, and that's
I
just
would actually
fascinating.
want to know that how are these things 3D printed because I've just heard these things in high concept movie
So,
or in stuff.
so the thing is, our body is capable of, so whatever part you introduce in your body, it needs to be neutral, and there are certain polymers that allow us to do so. So one good example is polyether ether, I think ketone. So polyether ether ketone is a material which is used, PEEK. So that is kind of a polymer which is used to design and print out objects for human body. And materials like these are then used to print whatever you want. So if your tooth is missing, if your jawbone is missing, or something else. So in terms of replacing bones, we can use metals. But yeah, we can also use such polymers to print out human organs.
Yeah. I mean, like Satvik said, it's basically either natural or some synthetic ones, or a combination of both, which will give you, like, if you're printing, let's say, a heart or something, what you want is it should be able to flex and stuff like that. So it all depends on what you want to have, like what that organ is supposed to do, and for that, what polymer you should choose. But other than that, I think it's just similar 3D printing. Basically, it's the choice of polymer which matters. So
So,
for
So
hard, for example, it matters that it should be able to contract and expand.
so these polymers are also known as organic thermoplastic polymers.
Yeah.
so when they say that, okay, so I had a doubt or a question. They say that you can culture parts of a body in a lab, culture as it grow. So is that
That is
more
No, no,
different. I think that
no, no,
is
that's a
more like
different
stem
story. Yeah.
cells and stuff. Yeah.
correct? Correct. So is 3D printing taking over that domain, or how is it?
No, no, that's a completely different take at how we can come up with replacement organs.
Okay.
It's also, I mean, it's again a very huge domain, and I think we don't have the proper expertise to either comment on any of those. But it has nothing to, from what I understand, it has nothing to do with 3D printing. That's a
No, no.
completely
I
different
think
game.
what his question is that is 3D printing a better replacement for that kind of technology, or is
Yeah,
it
because
doing that? So definitely
imagine
we don't have any numbers for it, but
yeah.
I think from what a little bit of videos I've seen about both of them, definitely 3D printing is moving towards that goal faster than stem cell research did, or growing the parts did. Uh, but maybe there might be some organs which cannot be 3D printed, they need to be grown and stuff like that. Whereas some will benefit from 3D printing. But like I said, I mean, I don't have enough knowledge to comment very expertly on that. But yeah.
So when do you imagine everyone, like a common man, will have a 3D printer on his desk at house, and then he will be able to,
I think that is today. That is today. It only matters if you require it. I mean, for a layman, they don't even require a paper-based printer on a daily basis. But if you are into architecture, if you're into design, if you're into robotics, if you are into DIY for that matter, if you are into DIY, you will be benefited by having a polymer-based 3D printer, and it would make more sense to you today, because
Yeah.
if you go on the Amazon, or if you basically Google 3D printer in India, you can buy it for a minimum of 25 to 30,000.
Yeah. Yeah.
what do you think about a lifestyle wherein, for example, say I have to replace a button, I have to replace a switch, I have to replace a tap. So if you can imagine,
That
if
that
you can
would be
imagine that
overkill. I think
once,
that would be overkill. So because the cost of raw materials,
okay,
I mean, in near future it can happen. Like, if there is something which has broken, you just 3D print, you can just scan and 3D print it.
right.
It's actually a very interesting proposal. But then, for these 3D printers to be that cheap and the raw material be universal, so even I would rather say it is governed by the raw material in terms of what objects we can print. So unless and until that becomes cheap or that becomes accessible, I think 3D printing will not make
So
sense
I think
to common man.
it's also limited by the fact that let's say, even if for a simple thing, like let's say you have a 3D printer and you don't have a button, and you want to 3D print it. That's fine, but you need to design it or be able to find a model of somebody else that has made a button model for that CAD software or whatever, that will be given to the 3D printer. But if there is not, so for example, my something small breaks, like let's say I have a keyboard and I want to put a leg on it which is longer than the provided one. Now I need to go and design that, right? And so you need to have that knowledge as well. So
Exactly.
that becoming very common can become a bottleneck for this. Um,
So, I mean,
yeah.
talking about software, I kind of missed this earlier. So, the problems that we were talking about, the fatigue strength or the fatigue quotient of a object that is printed using either of the methods that we
Mm,
discussed earlier. I was going through and reading through these articles, and interesting enough, I was surprised again that these researchers are actually using machine learning and incorporating machine learning algorithms to tell the printers what method or how they should actually scan, or what laser scan methodology they should choose
mm,
given the object that needs to be printed. So even machine learning kind of has implementations in 3D printing, wherein the 3D printer learns how to correct its mistakes, or at least minimize its faults.
mm,
Yeah.
yeah. Yeah, I think
Very cool.
yeah, I think this is again like a lot of interesting things can come up with this, but we are not subject matter experts, so this is what we guys know, and it's an interesting topic, so we wanted to discuss it with amongst ourselves. Um, but yeah, so that's I think it on the 3D printing side. I really hope that 3D printing does a lot of good things for us. And it was quite knowledgeable to know about these small and big things that 3D printing is doing, which Amod and Satvik mentioned, like all these jet engine parts or the rocket parts and stuff like that. Yeah. So I have a small fact. It's not too big today. We are going to have a shorter episode than usual today. So just a small fact about the moons in our solar system. So it's pretty easy to never imagine that there can be more than one moon, because we have one moon, right? But interestingly, Jupiter has 79 moons.
Yes.
And
What?
yes, and Saturn has 82 moons.
Yeah.
But not all moons are as big as our moon. Like the moons
No,
also
but then
include.
how many? Europa, Titan.
I
I
can't
can
name
only recall
82,
these two
but
names, but I only heard a couple. I only heard a couple of.
As time progressed, we could find out more objects that were, significant, that would be
yeah,
considered moons.
yeah,
Earlier, even I remember there were 18 or something like that.
yeah,
And as time progressed, uh,
Oh my God.
even till day, I did not know. This is the first time I'm hearing Saturn has
yeah.
82, which
Yeah,
is
and yeah, I mean the moon sizes vary, like it's from a few kilometers, like a few 10, 20, 30 kilometer wide, to like thousands of kilometer or something like that. So they are big and small, but they are significant enough to be considered moons. uh,
wow.
yeah,
Crazy.
Yeah.
79 for Jupiter and 82 for Saturn, until now at least.
So I
And
think till the 2020 count for Jupiter is 80.
okay, okay, I don't know from where I got the fact, it said 82, so uh,
Crazy, crazy.
maybe
Yeah.
some have been removed or added later. I don't know. Just like Pluto, and
Pluto will be jealous
actually,
of it.
yeah, maybe. And actually, like these icy moons have a lot of effect on the actual planets also. Like Titan, or which one is I don't remember the name of the one which is very icy, and it shoots out like kilometers high ice, stuff. Like
Europa.
we have geysers, so they shoot out icy water geysers. Uh,
Is it
from
Europa?
I think it's Europa, yeah, and that has contributed a lot to one of the rings, I think, or something like that. The ice rings around the planet, and it also affects the atmosphere to some extent.
Is it?
I think the best example would be Pluto, even if Pluto is not considered as a planet, but Pluto and its moon, they kind of all, I mean, to some extent, they have the same size, and because of these objects, they revolve in a very odd orbit around themselves. So the Earth spins on an axis, but Pluto spins on an axis, but also at the same time revolve around its moon,
Moon.
while its moon revolving with it in an
It's more like a binary
elliptical orbit.
system, basically.
Exactly.
Yeah.
Hey, did you know that the moon, our moon, Earth's moon, eventually, very long in the future, it will
Yeah.
come and.
It will
Yep.
crash onto
Yeah,
Earth.
it'll crash on.
So is
Yeah.
it the same for all the other moons and the
I
planets?
think until that
It
time we would
is.
be on Mars.
By that time, I don't think we'll even exist. But anyways,
Humans as a society.
yeah, I don't think we have too long a life to live. To be honest, on the scale of universe, I don't think
I think
we'll.
that's a different topic for another
Yeah.
day.
Anyways, yeah, but it is true for all moons because it's basically like it loses velocity as time goes by, and that is gonna cause it to start falling into the gravity. Like it won't be able to stay in orbit. It's the same as any satellite or any or even ISS, right? It stays in orbit, but they have to have jet propulsion or ion propulsion every some time to keep it in orbit. Otherwise, it will deorbit. So satellites, moon is a natural satellite. It's the same thing. If we can come up with something that can keep it, like it push it back into orbit, then yes, it will stay by that time. But if not, it will crash on Earth. Yeah.
Gravity tractors.
Yes. And I mean, the more you think of it in terms of fabric of if gravity as instead of a force, if you think of it as a uh, what is that as a wave, then it starts making more sense because if you look at that model where you have the fabric and you put Earth and it bends, and then there is moon, right? And it's revolving. It's gonna start going down and closer
Yeah,
to Earth at some point. So yeah.
pretty good.
All right. But that's it for the fact for today. Anything else you guys want to add?
Unfortunately, I could not be on video today. I'll correct my connection next time.
It's all
So
good.
hope you guys, hope yeah. So that would be all, and I think we had an interesting discussion on 3D printing, and I actually learned a lot of things which
Yeah,
are actually interesting.
me as well. Yeah, I think I'll go and learn some more from with those as pointers.
Yeah, I think even I need to brush up because I thought I knew a lot, but then as time progressed,
So it's like the more you know, the lesser you know.
yeah, that's
It's
it.
like that.
Yeah, it's a bulbulaya. Anyways, all
All
right.
right then.
Yeah, thank you everybody for tuning in. Thank you Amod for joining today.
You're
And
welcome.
that's gonna be it for today. I'm gonna stop the stream now. Thank you so much. Leave a like, guys.